This recording is a video tutorial for hypothesis testing for one-tailed test when the standard deviation is known. We are going to be looking at Chapter 9, number 47 on page 446 in our statistics section of the book. Reading it together, it says CEOs who belong to a popular business-oriented social networking service have an average number of 930 connections. Do other members have fewer connections than CEOs? The number of connections for a random sample of 7,515 members who are not CEOs is provided in a data file named Social Network. Based on historical data, the population standard deviation can be assumed to be known with a standard deviation of 250. Using this sample, test the hypothesis that other members have fewer connections than CEOs at an alpha of 0.01. Discuss the practical significance of the results. So we're looking to find out, the research question here is stated, do other members have fewer connections than CEOs? So you're looking at the CEO average has 930 connections. And we're looking to find out, again, what do non-CEO members have? So for me, it is easiest to start with the alternate hypothesis. In this case, HA is where mu is less than 930. So the social network connections of non-CEO members are significantly less than the CEO's connection average, or the mean, of 930. 930 is again pulled out of the problem itself, and we're looking at an alpha of 0.01, or a level of significance of 0.01. Using the p-value approach, we find that the p-value is 0.0021. And see if we can switch this to Excel. This here is the data file for Excel, the social network file, which will also be uploaded to Moodle. And these formulas here can be found on page 423 of Chapter 9 in Statistics. Notice again in the problem, it's actually giving you the standard deviation, and you're going to want to make sure that you're using the right formulas and the template for Excel, because 423 is going to be different formula versus when the standard deviation is not known, which is on page 433. Because you're looking for a little bit different information. If you've read your chapters, you'll find that you're using the population, when the population standard deviation is not known, you are going to end up using the sample standard deviation, which again has slightly different calculations. But here's the Excel file that has all the data. You're entering the population standard deviation, and you're having to enter the hypothesized value of 930. Both of these are pulled from the problem, and the rest of it is calculated for you based on the formulas that you have already entered. So again, p-value, we're going to switch this back over to the Word document. So your p-value, this is just copied and pasted from Excel. P-value is 0.0021 for a lower tail test. Again, you know it's a lower tail because when you're looking at the alternate hypothesis, mu is less than, so less than, lower tail. So p-value approach, decision rule is the same. If p-value is less than or equal to alpha, reject HO. If p is low, HO must go. So your decision rule, p-value of 0.0021, I standard use for decimal points, just for clarity's sake. So 0.0021 is less than the alpha value of 0.01. Therefore, we need to reject HO, meaning H null is false. So we need to reject the null hypothesis that, we need to finish this. Reject the null hypothesis that social network connections of non-CEO members are not significantly less than CEO connection average of 930 members. So stated in another way, I need to change this to chances are 99 out of 100, or 99%, because we changed our level of significance in this example to 0.01. Chances are 99 out of 100, or 99%, that a non-CEO member has significantly less social connections than a CEO member average of 930 connections. So this concludes the video tutorial for a one-tailed hypothesis test where the standard deviation is known. Let me know if anyone has questions. Thank you.